morning students. Today I am going to discuss about a very important topic, cardiac cycle. Yeah, many people will think on the cardiac cycle, that graph which contains volume changes, pressure changes, and many get confused with it, but it's actually very simple. When you are going to understand the concept, it becomes very easy. I will try to make it as simple as possible with concept oriented. So first let us go to definition of cardiac cycle. Cardiac cycle is defined as the sequence of electrical sequence. So it is an order of electrical and mechanical events from one beat to next beat. For example, lub, dub, lub, dub. This lub, dub is one cardiac cycle. Or cardiac cycle is from one lub to next lub. I hope you understand. Or simply we can say it includes one systole, which is contraction, plus one systole, which is contraction, plus one diastole. So this is one cardiac cycle, and the duration of one cardiac cycle is, note it down, 0.8 second. Lub dub is 0.8 second. So for 0.8 second, the heart is beating once. So what will be the heart rate? That is, heart rate is nothing but how many times your heart is going to beat, lub dub, lub dub, lub dub, how many times per minute, which is 60 seconds. For 0.8 second, the heart is beating once. So for 60 seconds, how much time it will beat? Simple. So for example, I will make it simple. See, lub dub. For 1 second, 1 beat means for 60 seconds, 60 beats. But it is not 1 second. Before 1 second itself, 1 beat is completed. 0.8 second. So the duration of cardiac cycle is 0.8 second. Cardiac cycle includes contraction and relaxation, systole and diastole. There is one odd beat. So 1 beat is 0.8 second. There is a definite relation between this cardiac cycle duration and heart rate. For example, instead of 0.8 second, so the normal duration is 0.8 second. You imagine the cardiac cycle duration is 1 second. So for 1 beat, 1 second, 1 second, 1 second. So for 1 minute, it will be 60. 1 beat, it is 0.8 second. So how many beats for 1 minute? So the heart rate formula will be 60 divided by 0.8. Very, very simple. So 1 beat is 0.8 seconds, but I want the heart rate for 60 seconds, which is equal to 60 by 0.8, which is equal to 75. So for the duration of cardiac cycle 0.8 second, your heart rate is 75 beats per minute, which is the normal heart rate. Imagine if the cardiac cycle is 1 second, so what will happen? Your heart rate will become 60 by, the cardiac cycle duration is 1, which is 60 by 60 per minute. One more example I will give. Imagine your heart rate is 200. So it beats 200 times per minute. So within 1 minute, instead of 75, the normal heart rate is 75. So instead of 75, it is beating 200. So what will happen to the duration of cardiac cycle? Obviously, it is going to be very, very less. Yeah, this heart rate has to come to 200. So 60 by what will be 200? That is the question. So 60 by 0.3. So only if the duration of cardiac cycle is 0.3, the total, which will be, your heart rate will come to 200. So before that, so instead of 0.8 second, see here, 60 by 0.3 is 200. So if your heart rate has to be 200, 200 means one systole and diastole will be only 0.3 seconds. When heart is beating very, very fast, there is no time for filling. So whenever your heart rate increases, the duration of cardiac cycle is decreased, and cardiac cycle is divided into systole, diastole, which we already discussed. When your heart rate is more, usually it is a diastole time which is decreased so much compared to systole. Both systole is decreased, diastole is decreased, but duration of diastole decrease is very much compared to systole. That also can be asked. For example, here your heart rate is 200, cardiac cycle is 0.3. Among this 0.8, that I will tell how much is systole, how much is diastole. The decrease in diastole is so much compared to, that is, filling time is very, very less. Before diastole, before filling, the heart contracts. Before filling, the heart contracts. That is why it is 200. So diastole is decreased drastically, DD. Diastole is decreased drastically whenever your heart rate is more. So now coming to the phases of cardiac cycle. Cardiac cycle is usually divided into atrial events and ventricular events. We all know the duration of cardiac cycle is 0.8 second. So atrial events is divided into atrial systole, atrial diastole. So systole is contraction, diastole is relaxation. Ventricle again, ventricular systole, ventricular diastole. So all these events is going, atrial, whenever atrial event is occurring, at the same time ventricle is occurring. I am just dividing it into phases. So don't think that this is separate, that is separate. That is, don't think that This is 0.8 seconds separate, that 0.8 second is separate. Within the 0.8 second, what happens to the atrium, what happens to the ventricle. So like that we are dividing. So atrial systole, note it down, atrial systole duration is 0.1 second and atrial diastole duration is 0.7 second. Ventricular systole duration is, all these are important, 0.3 second. Ventricular diastole duration is 0.5 second. Now whenever I go further forward into the cardiac cycle topic, mostly I will be discussing on this ventricle, left ventricle mostly, the ventricular systole, diastole. So that I will take one chamber of the heart. Simultaneously, whenever left ventricle contracts, right ventricle is also going to contract. So whenever the blood is pumped from left ventricle into aorta, the blood will be pumped from right ventricle into pulmonary artery. So this is same, but for understanding, I will take only one chamber of that. Mainly what I will be discussing is left ventricle. Coming to a very important aspect of this topic, the cycle. Why it is called a cycle? It starts from one place and ends at the same place. That is why it is called a cycle. So I will start with atrial systole. So you have to compare this diagram. This diagram is also, that's why I have drawn this diagram. So far I have not explained about this. Now see here. I will start with atrial systole. So note it down. Atrial systole is the last phase of ventricular filling. So in the cardiac cycle, there is a phase called ventricle filling, where the blood from atria will be entering into the ventricle. That I will be discussing, that what happens during the diastole phase. So one of the phase during ventricular filling is atrial, so I will write it. Atrial systole is the last phase of ventricular diastole, which contributes 20%, 20 to 25% of the volume filling of volume. So listen here, atrial systole, this atria contracts, because of that the blood from the left atria is forced into the left ventricle, or the left ventricle is filled. So obviously this is diastole phase, because ventricle is filling. I told I am going to take only left ventricle chamber for understanding. So this is diastole phase, no doubt in the two phases are there, systole, diastole. Now I am starting from atrial systole and I am going to discuss about the cycle of events, mechanical events. So the left ventricle is filling. One of the phases is atrial systole, or before atrial systole what happens is there will be slow filling. So the slow filling, the left ventricle is also filled, slow filling, which is passive, not active. Whereas atrial systole, where the atria contracts and the left ventricle gets filled, it is active phase. Here the left ventricle is just filling. So this is before. So slow filling. This is also diastole. Atrial systole is causing the ventricle to get filled more. So this is the last phase of ventricular diastole. Now, yeah, AV valves is open. Just understand, during this atrial systole, AV valves will be open. Or since we are taking left ventricle, I write it mitral valve is open. Yeah, now next phase. So the ventricle is getting filled. Now you have to imagine. So listen here, the ventricle is getting filled. Now what will happen? Ventricle will try to contract. As now the ventricle is filled with blood. Are you able to understand? Ventricle can fill up to 130 ml of blood. That is called end diastolic volume. So at the end of diastole, how much the blood is filled? 130 ml, up to 130 ml is filled. So once the ventricle is filled with 130 ml, now the ventricle starts contracting. So now listen here, the ventricle contracts. So now what happens? To prevent the backflow, again the already which was opened. So already the AV valves in atrial systole itself, the AV valves is open. That is the mitral valve. Now what happens? To prevent the backflow, again this is closed. So there will be closure of mitral valve or AV valve. So once the diastole phase is over, the systole phase starts. When the ventricle starts contracting, the valve which was open there in atrial systole, the mitral valve is just concentrate. When the atria contracts, the mitral valve is open so that the blood from the atria enters into the ventricle. This atrial systole is the last phase, which I will complete, the last phase of the diastole. Now once the diastole is over, the ventricle starts contracting, but to prevent the backflow, this mitral valve is closed. So closure of mitral valve. Now concentrate, the ventricle is contracting. You try to answer, pause the video and answer. Listen here. Now we are entering into systole phase. So now we are going to enter into systole phase. This is diastole phase. So cardiac cycle includes systole and diastole. Now the ventricle is contracting. These valves are closed to prevent the backflow. Similar valves are already is in closed state. It is at already it is in closed state. Now listen. So what is status of AV valve? Closed. What is the status of aortic valve? That is semilunar valve? Closed. What is ventricle doing? Contracting. Are you able to understand? So this phase is called isovolumetric contraction phase. Iso means same. The volume remains same because listen here, both valves are closed, but the ventricle is contracting. So during this phase, what happens? There will be increase in ventricular pressure. So during isovolumetric contraction phase, there is increase in ventricular pressure, and the closure of that is also very, very important, which causes first start sound. Note it down. We all know closure of AV valves is responsible for first start sound. So the first start sound occurs at the time of isovolumetric contraction phase. So they can ask, when the closure of AV valves occurs, during which phase? The closure of AV valves occurs during isovolumetric contraction phase or at the start of isovolumetric contraction phase. So once AV valve closes, the isovolumetric contraction phase starts. Why AV valve closes? When the ventricle starts contracting, to prevent backflow, AV valve closes. Here the mitral valve closes. So mitral valve is closed, semilunar valve is closed. All the valves are closed. So no going out of blood, no coming in of blood. That is why iso means same. And contraction is occurring. And because of this, during this isovolumetric contraction phase, what happens? There is increase in ventricular pressure. So next step, as the pressure increases, once the pressure is greater than 80 millimeter mercury. So normal aortic pressure during diastole is 80 millimeter mercury. So once the ventricle, now imagine, you have to imagine ventricle is contracting against the closed chamber. Ventricle is contracting against closed chamber. So now as the pressure increases, what happens? This opens. So because of this increase in pressure in 80, the aortic valve opens, very, very important. So aortic valve opens. So now what will be the next phase as the aortic valve opens? Yeah, ejection. So for ejection, there is rapid ejection, slow ejection. So all these are systole. So the blood is pumped out. So now during ejection phase, once the pressure increases more than 80 millimeter mercury, which is the aortic pressure at diastole. Yeah. So this is ejection phase. So first is rapid ejection. Initially more blood will go, then slow ejection phase. Once most of the blood, how much blood was collected? 130 ml. So out of the 130 ml, some blood starts going because of the contraction. First is rapid ejection phase. Next is slow ejection phase. Now what happens once the blood goes? So now the pressure decreases. So there will be decrease in ventricular pressure as the ejection phase is about to complete. Just listen, the systole is about to complete. Systole, diastole. Now we are discussing about systole. Isovolumetric contraction, rapid ejection, slow ejection. Now the ejection phase is about to complete, and what happens? There will be decrease in ventricular pressure. Once the pressure decreases, the aortic pressure is greater than ventricular pressure at this stage. So what happens? This pressure has decreased. Are able to understand? So what will happen? There is chance of backflow. So now what happens? To prevent backflow, the aortic valve closes or semilunar valve closes. So note it down, and this is responsible for second heart sound. So the aortic valve is closed, semilunar valve is closed. Now again see that. Now see, now the condition, see the diagram. This valve is closed, aortic valve, which was opened during ejection phase here. I have not marked aortic valve opening. Yeah. So here you can see this aortic valve is opened and the ejection phase is occurred. Once the ejection phase is about to complete, the ventricular pressure decreases. As this pressure decreases, to prevent a backflow, because this pressure is more now. This pressure is more than this pressure. During ejection phase, this pressure was more. So the pressure forced the aortic valve to open and ejection occurred. Blood is moving out of the left ventricle into aorta. Once the ejection phase is completed, the pressure is there, this pressure is more than this pressure. So what happens? There is possibility of backflow. To prevent that, aortic valve closes. And we all know closure of seminal valve causes second heart sound. So now since this aortic valve is closed, what happens? All the valves are closed. Just concentrate. Now this phase is called isovolumetric relaxation phase. Iso means already I discussed. Same. Why same volume? This is also closed. This is also closed. But here it is relaxation phase. This systole phase has ended. So this is isovolumetric relaxation phase. Here the systole is ending, and so here the diastole is ending and systole is starting. So this is isovolumetric contraction phase. So in systole also there is one isovolumetric, that is isovolumetric contraction phase. In diastole also there is one isovolumetric, that is isovolumetric relaxation phase. So protodiastole. So protodiastole, that is also one of the phases of cardiac cycle. Already discussed isovolumetric relaxation phase, where the aortic valve is closed. Why the aortic valve is closed? To prevent the backflow. Now this valve is closed, this valve is closed. This is called isovolumetric relaxation phase, which is just after the protodiastole. So protodiastole phase is immediately after systole. So protodiastole, getting ready for the diastole, getting ready for relaxation. So protodiastole, then isovolumetric relaxation phase. So now the question is, second heart sound is caused by closure of seminal valves. Second heart sound occurs during which phase? Second heart sound occurs during protodiastole phase. Note it down. Now what happens? Now what happens? Ventricular pressure. What will happen to ventricular pressure? It is decreasing because all the blood is pumped out. So decrease in ventricular pressure. So now what happens? Atrial pressure will be greater than ventricular pressure. So what is expected? Yeah, this has to open. Yeah, now again because of this, AV valve opens, or mitral valve. If I take left ventricle, it is mitral valve. Mitral valve opens. So because of this, there is going to be the next phase, rapid filling phase, then slow filling phase. Slow filling phase is also called as diastasis. Note it down. Why the filling occurs? This valve opens. Why this valve opens? The ventricular pressure decreased too much. Why it has decreased? All the blood is ejected. So this pressure decreases. So this pressure is more than this pressure. So what happens? The blood has to come from left atria into left ventricle. For this valve is opened here. AV valve is opened. As the AV valve opened, there is filling. And reason here, now all this is diastole. So this is also diastole. Diastole. So this is also diastole. Okay. So in diastole there is a rapid filling phase, then slow filling phase. Slow filling phase is also called as diastasis. 70%. So 70% of filling of your left ventricle is by this rapid filling phase and slow filling phase. The 20 to 25% or 70 to 75% in fact. So 70 to 75% is by rapid filling, slow filling. 20 to 25 or 20 to 30% is from atrial systole. I started with atrial systole. See here, I started with atrial systole and then I am ending with atrial systole. So this entire thing takes place 0.8 second, and this is systole phase, this is diastole phase. Diastole is 0.5 second, systole is 0.3 second. The entire duration is 0.8 second. So once for summary, cardiac cycle is the sequence of electrical and mechanical events that occurs from one beat to next beat. Then I discussed about the relation between cardiac cycle and heart rate. For example, if your heart rate is 200, tap, 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 tap. So one cycle will be only 0.3 seconds. Then coming for the sequence of the events which occurs in cardiac cycle, just to concentrate, atrial systole is part of the ventricular diastole phase. So it is a part of diastole. I am taking left ventricle chamber for explanation. And atrial systole is the last phase of rapid filling, slow filling, atrial systole. So all these from protodiastole, just note it down. Yeah, that also I want to tell. Atrial systole is 0.3 second, which includes isovolumetric contraction phase, which is 0.05 second. Rapid ejection phase, which includes 0.10 second, and slow ejection phase, which includes 0.15 second. So this total will be 0.3 second. For ventricular diastole also, it starts with proto diastole, isovolumetric relaxation phase, then rapid filling phase, and slow filling phase, then atrial systole. Remember, atrial systole is 0.1 second, no doubt in that. Already we discussed. So, and closure of AV valves causes first start sound. So, first start sound occurs at the onset of isovolumetric contraction phase, noted down. And closure of seminar valves, aortic valve, causes second start sound. And closure of aortic valve occurs at the protodiastole stage, that is just the onset of diastole, where the pressure decreases, the protodiastole starts, and because of the backflow, the aortic valve is closed. This closure causes decrease in pressure, aortic pressure is greater, so to prevent that, the seminar valve closes, which causes second start sound. Once the seminar valve is closed, that is called as isovolumetric relaxation phase. That is actually very important. I have drawn inside isovolumetric relaxation phase. During the isovolumetric relaxation phase, what happens? As this pressure is very less, you can see here the mitral valve opens. As the mitral valve opens, rapid filling, slow filling. Slow filling is also called as diastasis. Both this rapid filling and slow filling is passive, because from higher pressure to lower pressure, no problem. But this atrial systole includes the contraction of the atria. So the atria contraction also contributes to ventricular diastole. Around 20 to 25%. Some books it is given as 20 to 30%. So that also you can note it down, which is the last phase. So this cycle keeps on going. So this is the how the cardiac cycle functions. So today in this video I discussed mechanical events that occurs. So even without drawing this, you try to imagine. So whenever I was explaining any event, you have to imagine these two valves. So now I will ask some questions. What will happen to the ventricular volume during isovolumetric contraction phase? You pause the video and try to answer. The answer is same, because iso volume, same volume. So no blood is going to go out, no blood is going to come in. So it does not increase, the ventricular volume remains same. Now next question. During ejection phase, what happens to the pressure in the ventricle? Increases or decreases? Simple. During ejection phase, when the ventricle is contracting, the pressure starts increasing. Because of this increase in pressure only, this valve opens. This aortic valve opens and rapid ejection, slow ejection phase starts. So like that, you should be now able to answer. In my next class, I will discuss, the cardiac cycle is not complete. This is just part 1. I have just told the sequence of events. Another important aspect of this cardiac cycle is, in next class I will discuss about the volume and pressure changes. What are things that happens in the diagram, which you people get confused very much. Now I have explained the concept, so it is going to be easy. Class I will be marking that ECG, heart sounds, atrial pressure, ventricular pressure, where the valve closes, where the valve opens in the schematic diagram, and based upon this concept, you will be able to explain. So in the next, what I am going to do in the next video is, I will just put the diagram. You will be able to see the diagram and it will be self-explanatory. As already we know, what about isovolumetric contraction phase, what about isovolumetric relaxation phase, all these things. So I hope you understood about the mechanism of the events that occurs during cardiac cycle. So in next class, I will discuss about the diagram of volume changes and pressure changes during the cardiac cycle in the diagram format. Thank you. We will meet in next class.